欢迎这个 Chris 给大家这个分享，来，大家掌声欢迎。
Thank you. I understood a little bit of that. I just said Megua, America? Yeah. Although my tones are terrible. So this is visualizations using SVG, Canvas, and WebGL. We had a talk earlier today about visualizations. This will be less advanced than that one. We won't be going into how to optimize things. This will be more from a user perspective, from your perspective. How do you use technologies like SVG, Canvas, and WebGL? And I'm going to be talking about particularly in Vue, since I'm Chris, I'm on the Vue team, and I hear Vue is quite popular in China? Yeah. How many people are using Vue? Wonderful. Okay. We have a few converts left, but you can attack them afterwards. So before I go too far into the specific technologies, I want to talk about what I mean by visualization. So visualization is just taking some kind of data, some kind of information, and turning it into something that's easier for people to understand. You know, because if we just see information in text all the time, that's often kind of boring, and it's often difficult to read. It's often difficult to find information quickly. Does anyone recognize where this particular visualization is from? You can shout it out in English, please. Yeah, so this is Webpack Analyzer inside of Vue CLI to show you like the different sizes of things in your Webpack build. And this is very useful because with something visual like this, we can very easily and quickly see what's taking up the most space. Now, my goals in this talk are, first, I want you to understand why you would use some of these technologies. I want to expose you. I want to show you some simple use cases of these technologies, show you what the code looks like, hopefully get you familiar with them. And I'm curious, how many people have used SVG before? Raise your hand. Okay, yeah, some, but most people haven't. What about Canvas? And WebGL? Oh, very few hands. Maybe just, I can't see, maybe it's just like Wu Liang back there. Oh, here are a few hands too. Okay, good. But relatively few. I also want to show you some tips and tools that can make working with these technologies easier. And these slides are actually a playground for learning how to use these technologies, experimenting with some simple examples. I'll be sharing the link at the end. I have checked to make sure that it will be accessible. So first, I want to talk about HTML. There's a lot of visualization that you can do in HTML. First, you can make boxes. You can make these rectangles. Probably everyone who's done some kind of web development has at some point made a rectangle with HTML, whether you realize it or not. And this looks relatively simple. This isn't too bad if you're already into web development. A little bit of HTML, a little bit of CSS. And you can also make circles, sort of, by adding a border radius. Yeah, it's a little bit hacky, but it works. You can get a little bit more hacky and start making triangles and shapes like that. But after this is really where HTML starts falling apart. You know, I've done some hacky things with HTML before I learned some of these other technologies. For example, creating a bunch of rectangles and placing them on top of each other to create different shapes by basically making like really small ones and then big ones and then circles to round things out and imitate some shapes that otherwise would be impossible. And it's actually a bunch of different elements when it might seem like only one or two elements, and in SVG it might only be one or two elements. So why not just use HTML? First of all, I thought about redoing this with China, but I thought that would take too long, and I wasn't sure where to get the data. So sometimes you want really precise shapes. So in borders of countries, you often have like really fine lines. And if you can try to imagine building something like this with HTML, just with divs, it's technically possible. You could even create it dot by dot if you wanted, but it's going to be a huge pain. It's going to be a real headache. Sometimes you also want high performance. You know, you have some visualization that is running every frame, and you want it to run really quickly, in this case at 60 frames per second. By the way, does anyone recognize this visualization here? Go ahead and shout it out. It's Conway's Game of Life. It's a pretty classic visualization, and also is quite nice for testing performance. You also sometimes want things that are in 3D, like this logo from Vue.js London. And you also sometimes want to be dynamic and interactive. You want data that is constantly changing and animating. And having access to the GPU, to the graphics processor of the computer, with Canvas or WebGL can be very useful for these kinds of visualizations. This is an example of an interface from a library built off Vue called Zirkel, by the way. So now let's go into the first technology, SVG, which stands for Scalable Vector Graphics. You do not need to remember that. I only remember it because I've taught it a few times. And this is an example of some relatively simple SVG code. Just like our HTML, we're drawing a gray rectangle. You couldn't have a more boring visualization. And in this case, we have access to some new elements that you might not have seen before if you haven't used SVG. There's an SVG element and a rect, which is short for rectangle. And inside of the SVG, we control the position of the rectangle with X and Y coordinates from the top left. And we can also provide a width and a height. Even if you've never seen SVG before, you might have guessed what this is doing and how it's working just from your past programming or math experience. Now, styling SVG elements is also similar to HTML, but a little bit different. Just like with HTML, where we have to, or just like with the XML, where we have to learn some new element types, you also have to learn some new CSS properties. For example, fill instead of background, stroke, instead of border or border color, and stroke width instead of border width. But besides learning that, we can mostly reuse a lot of our skills from HTML. You know, the way we're writing and defining CSS is the same, you know, just some new properties. And the way that we're writing XML is the same, just some new elements. And something really, really nice about SVG is you can use it just like HTML. So for example, this is something I put together with Vue, where I have some controls. I'm using Vue's V model. And this X, Y, width, and height are bound to the rectangle. So I can change where it is within the SVG, which is in blue. And when you look at these slides later, this is one of the examples where if you click on the code, it'll actually open up a code pen so that you can play with this and experiment. Try changing some of the code yourself, try adding something new, and play with SVG, see how it works. But the nice thing about this is we can use vModel and other Vue directives and other Vue features just like we would with HTML, and it works the same way because we're still working with the DOM. We're still working with XML. SVG also allows you to create a wider variety of shapes than you can with HTML. We have not only Rex and Rex with a border radius and circles and ovals, but we can have lines and polylines and polygons. And this one here is a path. All of these are drawn. This is not an image. And there are even more than that. Now, when you're experimenting with technologies like these, I highly recommend prototyping as you learn or playing as you learn. You know, this is an example of a demo that I built for the Vue docs, for our state transition docs. And I probably maybe an hour putting this together and, you know, tweaking it and simplifying it. And then I spent the next 5 hours probably playing with it and just seeing what kind of crazy things I could make happen. And some of these things you won't even realize, you won't even think about the fact that you can do this with this technology until you start really playing with it. You know, I could turn this up and realize, like, oh yeah, I could create some like animation of some bacterial cell or something like that. Or this could be a really cool loading animation, perhaps. And all this is one polygon with a circle around it. It's just a shape where we're changing the number of sides, we're changing the radius from the center, and how often it updates with an animation. And this is not that much code. But I'm going to go through some specific parts of it in the following slides. So how many people have used The green sock animation platform, GSAP. Raise your hand if you've used GSAP before for animating. Oh, it's absolutely wonderful. I use this all the time for calculating different animations and state transitions. And in fact, we use GSAP for Vue's state transition docs. And one downside to some visualizations, I don't know that much about the education system in China, but if it's like how it is in Western Europe or in the United States, then you probably learned some math and you weren't sure why. And maybe you asked your teacher, like, when do I ever actually use this? Like, what problems does it solve in the real world? Is that something that people also experience in China? Yes? So I never got any satisfying answers, but this is one of those things that you can use trigonometry and sometimes calculus for. So this is some trigonometry that I'm using to figure out where each point should be in this polygon. And you'll see some things that may look familiar depending on what kind of math you took, like sine and cosine and pi. So for some of these things, it can be useful to maybe go back to an old math textbook or just do a quick search online and find some tutorials for, how to do the thing that you're trying to do. Oftentimes when I need to brush up on some math, I just look it up as I go. Look, how do you calculate whatever it is? And then I can find some resources and learn more about it. Now, unfortunately, SVG is slow, just like HTML. We don't have access to the GPU. Doing everything on the CPU makes things go kind of slow when we're doing intensive graphical operations. So for example, here's our Conway's Game of Life example with SVG. And we're not quite going at 60 frames per second. In fact, I'm going to make it a little bit worse. I'm going to increase the number of cells that we're rendering, hopefully not so much that I crash the computer. Okay, so we're up to 12,000. We're down to 14, 18. Let's push a little bit harder. Let's see how much we can make the computer cry. Okay, we're down to 10 frames per second. And looking at this, you can see how it's not completely smooth. It's a little bit jumpy. Like, not only are we getting a slower frame rate, but we're also not getting a very smooth experience even with that frame rate. The frame rate is jumping quite a bit. Now, there are some ways to make SVG and HTML visualizations a little bit faster. And I'm going to share some of those tips right now. First, it can be quite expensive to render an element and then unrender it rapidly, back and forth. And in that example that we saw, we have basically a bunch of squares, a bunch of pixels, and they're either on or they're off. They're on if they're light green, and they're off if they're dark green. And there are a lot of areas where the same dot the same square is just turning on and off, on and off, on and off all the time. So you can make this faster by hiding elements that should not be rendered instead of frequently adding and removing them. So for example, in Vue, you would do this with perhaps vShow instead of vIf, or having a filtered list and only rendering the boxes that you want to. So this way we render all of the boxes. They're always there, but we only show them. We just change display none to display block instead of having to actually add a new element to the page. It can also be useful to cache derived values. And in Vue, you can do this with computed properties. So this happens to not be a very expensive operation. But sometimes there are very expensive operations that you're doing that won't be changing all the time. And in that case, it can be very useful to cache these values, render them once, or calculate them once, and then reuse that value every time. So you don't have to rerun that calculation every time anything changes. And it's also a good idea to clean up any infinite loops that you create so they don't become memory leaks. For example, I'm running a method called evolve every animation frame with request animation frame, which is part of the browser API. But this is essentially like an infinite recursive function. I never tell it to stop. So I make sure that it does stop before this is destroyed. Otherwise, this presentation would be running the simulations from that slide even after I've moved on to another slide, even after it's no longer rendered on the page. But there's only so much you can do. There's only so much you can do to speed up HTML and SVG visualizations. So when you do need something that really pushes the limits of your computer, or most importantly, the computers of your customers or client, it's better to use Canvas or WebGL. So here's that same example with Canvas. And we're once again rendering the 17,000 cells at a time, but now we're at 60 frames per second. And we can even push this a little bit further to see how much more performant it is. In case you don't remember, we are at like 9, 10, 15 frames per second. Still going pretty well. Woo! Okay, we're starting to get it to go a little bit slower at 30 frames per second with 129,600 cells in the screen, which is pretty good. I'm pretty happy with it. And there are ways that we can make this even faster. But this is already very possibly acceptable. Now, unfortunately, Canvas and WebGL are not XML-based. You can't just drop elements in the page and be able to use these technologies. Instead, we'll drop for Canvas one element, which is the Canvas element. And then the rest is in JavaScript. We'll create a context. And then with this context, we can fill style to decide a color that we're going to draw with, and then fill a rectangle with this color, And this part may look familiar. Here we have our x, y, width, and height. Just like with SVG, except we have them in arguments instead of attributes, which is a little bit unfortunate because they're not labeled. So if you don't already know how to use fillRect, there's no indication of what it's doing unless you use comments or something like that. And I have a few tips on getting more performant canvas. This is reusing most of the same code as the SVG example. So there's not that much that's different here. But one of the tips that may not seem obvious is that it's good to minimize your operations as much as possible. Minimize the number of things that you have to do. This is a general rule. It's not always true. But as a general rule, it's better to clear the entire rectangle and then redraw all of the squares that are on every tick, rather than trying to be really efficient and only redrawing and toggling off all of the ones that were previously on and toggling on all the ones that were not on but now have to be on. Because actually it's very, very fast to just wipe the slate clean. It's also good to optimize wherever you can. You know, in most cases in JavaScript, you know, some people will argue with you on a pull request, hey, you should have used a for loop instead of for each. Or, you know, you shouldn't use map in this case because it's a little bit slow. How many people have gotten comments like that on a pull request where they're using for each or map or something like that, and someone has told them that, you know, they should use this other thing in JavaScript because it goes a little bit faster? Yeah? Okay, quite a few people. And I think most of the time that isn't really necessary. Most of the time it doesn't matter, it's not a bottleneck. But in cases like this with data visualization, it really can be. So this is where it can be useful to bust out that geek knowledge and knowing like which ways of iterating over an array and doing other things in JavaScript is actually faster, is better optimized by engines. So we're using a for loop here, or nested for loops, which gives us a little bit of extra speed, but it does make a difference. It is measurable. And besides that, there really isn't anything new or different that you have to know for optimizing Canvas. At least these are the top tips that can help you in the majority of situations. You know, there are other optimizations that sometimes come in handy, but these are the ones that are relatively easy to remember and apply in almost every kind of visualization. And once again, this, just like all the other demos, if you visit them in the slide links that I share at the end, then you can check them out, you can play with this. So now what does this look like with WebGL? We've seen some HTML, some SVG, some Canvas. If we want a rectangle with WebGL, we first might define a vertex shader, then a fragment shader. This is a special language that you're probably not familiar with. for writing shaders in WebGL. And then we have just a little bit of JavaScript. Now, you may be thinking, that seems pretty complicated. But I want to assure you, it's not always this complicated. It's usually much, much more complicated because we're just drawing a rectangle. And this is all of the work we have to go through just to draw a rectangle. It's absurd. When I was first learning WebGL and trying to do literally this, just draw a rectangle, I was so frustrated. I had to look at like 10 different tutorials just to figure out how to do this. It seems like it should be the simplest thing. So I actually recommend avoiding writing raw WebGL unless you like hurting yourself. It's really not a pleasant experience. Or unless you're like a legend, like Wu Liang. So instead, I recommend using tools that build on top of WebGL, like Mesh.js, which you learned a little bit about earlier today, and 3.js, and A-Frame, and Mapbox.gl. There are a lot of different libraries that build on top of WebGL, and also build on top of Canvas, to give you a much, much better interface. So some of you may be thinking, like, why would I use WebGL over Canvas? I mean, in many cases, you can get some better performance out of WebGL. But for most of the things that you'll want to do, that probably doesn't matter that much. So I think the main reason to use WebGL over Canvas is actually is this going to work? This demo isn't loading. Okay, well, I'll show you. I'll just explain what was going to appear here. It was going to be the text 3D, and then I was going to show you that the text 3D was 3D by zooming in and around. And it would have been really cool. And I would have gotten a spontaneous round of applause. But unfortunately, it didn't load. So 3D is really, really useful. Or WebGL is really, really useful for 3D. And one library that you may be particularly interested in for doing 3D things is A-Frame. Now I'm going to try to position this microphone a little bit to show you that this rectangle is actually 3D, only one-sided. And I have a little bit of lighting there, if you can make that out. Oh, I got it. Thank you. That's it. So drawing this rectangle, which also happens to be 3D and gives us some nice control so that we can move around and inspect this 3D rectangle, is much less code than the raw WebGL that we were writing. Because A-Frame actually allows us to drop in elements, custom elements, and the elements translate to WebGL. So we set a scene, and then we have a plane. A plane is just a 3D rectangle. And then we have a camera, which is where we look at the rectangle from. And by default, it adds a little bit of lighting and things like that so that you can actually see the rectangle. That's why it's a little bit brighter near the top here. And it's so much easier than writing raw WebGL. And you can, similarly, use the same tools and libraries that you're used to with HTML. So for example, if you're writing Vue, you can bind to these attributes. And they'll update and update the scene whenever Vue's reactivity system updates. And a more complex demo with a frame that will be hopefully loading soon that you may be interested in. We might not get it. But it was basically, here we go. And may not load all the way. But basically, this is that 3D Vue logo that I was showing you earlier. And you can walk through all of the code and see how it's done. The main A-frame code is just in a vPyramid component. And oh, we don't even get syntax highlighting yet? Come on, hurry up loading. But basically, to create a pyramid, we're just creating a bunch of triangles and putting them together. So you can take a closer look at that and play with it and experiment, add some new things, change the lighting, make it a different logo. Now, some general tips and review. When trying to optimize data visualizations, I want you to keep in mind, no matter what library you're using, if you're in development mode, it's going to be slower. So if you're using Vue, if you're using React, whatever it happens to be, if you're in development mode, it's not going to render as quickly as it will in production. So I often recommend making sure that you actually have a performance problem in production before you actually test it. Because I've seen people spend a whole week on a performance problem that they noticed while they were developing that doesn't actually exist in production. And so it is technically faster, but it was never slow in the first place, and they basically wasted a week. And they're expecting at the end of that week to get a round of applause, and everyone thinks they're really smart. And instead everyone says, I don't think there was a problem. Actually, it's really fast. If you check it out on the site, it's working fine, even on an old computer. So make sure you have a problem in production. Remember to optimize repeated operations. In Vue, you could do this with functional components and also using vShow instead of adding and removing with a filtered v4 or with vIf. And I highly recommend, no matter what component system you're using, it's great to componentize imperative code. So when you're using something like Mapbox.gl or Mesh.js, which gives you some imperative code that you can write, you can turn it into components that you can use together. So for example, you can simplify, in case you have an application where you just want to create boxes for some reason, the code that we just had, so that you can create a WebGL canvas and WebGL box, and use this basically with a similar interface to SVG, with the same kinds of props. And if you're already used to SVG, that could be a really nice developer experience for you and your team. And allows you to reuse this complex visualization code across your application without every dev knowing how to do these visualizations. That's really important. And views provide inject is really helpful, or React's context, for these kinds of features, so that you can share that context. Some libraries I really recommend. GSAP for animation, once again. Definitely check it out. And by the way, all the underlined text in these slides is links, so you can check them out later. A-Frame for 3D, or Vue Babylon.js, which I haven't used as much, but a lot of people really enjoy it. And D3 is a library I haven't talked about that is really nice for math utilities, for the math that you don't want to do, but you sort of have to do, but you don't really want to learn it. So how many people have used D3 in here? I'm curious. Quite a few people. And keep your hand up. Keep your hand up. And keep your hand up only if you enjoy the way that D3's rendering works. Don't lie to me. No, I absolutely really dislike D3's rendering model. But the nice thing about it is with modern versions of D3, I think starting with D3 4, you can actually use just the math utilities. You know, they're in separate Git repositories, and pull those in to do the math, and you can still do the rendering with Vue or React or whatever you're already using. And you don't have to fight with D3 over control of the DOM. And I have, I think this link, yeah, this link is an example of how I do that with Vue, of how I like to do it. And most important, you have to have fun. Like, create things that you'll want to play with, or else you'll never discover like what the different kinds of things that you can make are. And because some of this stuff can be a little bit complex and require some extra learning, making something fun is going to motivate you a lot more. And if you make something that you have fun with and you want to play with afterwards, I think it's very, very likely, it usually happens, that your boss also really likes it and wants to play with it, your colleagues really like it and want to play with it, your clients really like it and want to play with it. And a lot of times when there are so many apps that do the same thing, having yours just be fun can be the difference maker. That can be what sets you apart from the other applications. And one way to make things really fun is with GSAP animations. Just starting to animate something automatically makes it more fun. And the animation can be as simple as code like this. And that's all. This is the panda that I saw yesterday. He was very tired. I also want to give a huge, huge thank you to the FE Day organizers who have been fantastic hosts. I've actually learned a lot, even despite having very poor Chinese. And I think I've already gained like a little bit of weight in just a few days from all the good food. You can find me on patreon.com/ChrisViewFritz. I want to give a big thank you to John Leiter from Vuetify, Rolf Haug from Vue School, Greg Pollock and Adam Jar from Vue Mastery, and Ben Hong from Ben CodeZen, who are my Vusionary level sponsors and make it possible to do education work like this and do a lot of Vue work. And you can find me everywhere at ChrisViewFritz, including WeChat. And you can find these slides at fritz.netlify.com/slides/visinview. And you won't need a VPN, I think. Thank you very much for your kind attention.